Hello, and welcome to this presentation about detecting security vulnerabilities in PowerBuilder code using a tool called Visual Expert. A word about the company Novalis, who developed this tool. We're a software vendor, and we're providing tools for PowerBuilder and .NET developers for a very long time. Among them, I can mention Visual Expert that we're going to use today to analyze code, provide cross-references, documentation, and code inspection. There's also Visual Guard that we will present in a separate session that is meant to implement modern authentication, authorization, and audit features, in particular for PowerBuilder applications. Today's agenda, the context is that you may have to detect and remove security vulnerabilities from your code, and that's usually done by reviewing thoroughly the code and checking this code against a certain number of rules. You can do that manually, of course, which would take time anytime you have a new build, or you can do that automatically and repeatedly with a tool like Visual Expert. So in today's session, we will see, first of all, how to scan PowerBuilder and PowerScript code for security issues, how to locate flows at instruction level, produce some statistics and graph to have a high-level vision of the security and quality of the code, how to generate report, to list all the issues and share them with your teammates, how to fix issues and secure the change, which means avoid negative impact after you make the change, and how to automatically do some security scans for new builds in a continuous integration workflow. So let's start with a word about the tool we will use to detect vulnerabilities called Visual Expert. In case you want to use it later, you will understand the different purpose it can serve. So basically, it's a tool that will analyze your code, extract a lot of information, and provide a wide range of features. To make it simple, I'll group it in 5 categories. Number 1, you will explore dependencies to understand the consequence of a change. That's what we're going to use after we detect the vulnerabilities to make sure that we do not break the application on a change. You can also generate documentation or understand and describe a complex existing legacy code. You can compare different versions of your application. You can review the code, and this is where we will detect security vulnerabilities. And finally, you can also analyze the performance of database code. That's not something we're going to use today. And how does it work? First of all, we have some code parser that understand the grammar of the code and extract this description of all the items, dependencies, check each object against certain rules. That's where we can detect vulnerabilities or quality issues. This information is extracted and saved in a repository, a database, that one person can use later, a developer, to analyze and get results on screen or export them into different type of document, report, etc. And that can happen on one single seed. For example, in case you want to give it a try on a small piece of code, that's fine. But if you're working on a large project, and in particular, if there are several people in the team, you probably want to run the code analysis and the vulnerability detection on a server. And then you will have each person of the team that can concurrently access the repository to get results or impact analysis to check the consequence of the change before or after doing it. You can schedule this analysis and the documentation or the report that we generate for detecting vulnerabilities. That's something we will talk about later also, in case you want to automate this process for every build, in particular in the context of a continuous integration. Okay, let's see how it works and do some clicking. First step, we have to select and scan the code. So this is a Visual Expert, and in particular the wizard, where we can choose some code. So in our case, I'm going to start with PowerBuilder language because that's what we're going to analyze today. But you can also include additional languages, Oracle, SQL Server later on if you like. We have then to select a certain version. So let's start with the latest one, PowerBuilder 2021. And you can fetch code from various sources, from AWS, SVN, Git, which is getting quite popular these days, TFS, or directly select files and target from Windows folder. So I can go this way. It will suggest the workspace is opened recently in the PowerBuilder IDE, where you can select one or several targets if you like. And then you will give a name to your project. A few additional settings, but that we'll skip for today because that's not so important. And the code analysis is starting. Not only to read and understand the code object dependencies, but also, like I said, to check each object and methods against a certain number of rules, and in particular, security rules. This is how we detect vulnerabilities. Everything will be stored then in the repository that I mentioned just before. The duration of the code analysis obviously will depend on the volume of code that you have to analyze, but also the resources available. So in case you want to analyze a large volume of code, it's very important to follow the system requirement. And we do recommend running on a server because then you can schedule it later, do it at night or whatever. But checking the resource available is a very important step if you're looking at analyzing a large volume of code. Once the analysis is completed, Visual Expert will show this dashboard with some key statistics and trends. On the top of the dashboard, you will find some metrics about the reliability of the code with the number of bugs reported. What's interesting for us today is the security metric with the vulnerabilities found in the code, maintainability issues, percentage of command, etc. In the next section, you will find issues sorted by type and severity. You will find here the section about the vulnerabilities. Most of the issues are related to the maintainability. And then it's sorted here under a different angle of the severity, major, critical, etc. Below that, you will have an estimation of the cost to fix bugs and vulnerabilities right here with a breakdown per severity, and an estimation of the cost to address the maintainability issue that is called technical debt. Again, with a breakdown by severity. So let's focus on the vulnerabilities that are of interest for us today. If I double click on this chart, I drill down to the particular section I've selected, in our case, vulnerabilities. And I will see some trends. Each time I will analyze the code again, I get a new snapshot and I can see the evolution of the number of vulnerabilities found in the code, which is reducing a bit in that case. And that's the evolution of the remediation cost, the cost to fix them. That is also evolving for each code analysis. Then below that, you have all the rules that were broken or for which the code is not compliant. And for each rule, you have the number of issues found. Now, if I double click either here or there, I go to a lower detail. And that's where I can get a detailed list of the places in my code where a certain rule is not followed or broken. Let's take an example like IP addresses should not be hard-coded. If I click on this one, first of all, I have some documentation about this rule with examples of non-compliant code and sometimes compliant code to clarify if needed. And then I can find here the exact location of the code that is not complying with this rule. So in that case, it's in a single method where I have 5 issues. For each issue, you can see there's a red pin and a yellow background to highlight it in the code. If I want to try another one, I can get, for example, the places where I'm using old protocols that now should be no longer used and replaced with more recent ones that are more secure. Again, if I click here, the rule and the documentation is listed here. In this case, you have more examples of non-compliant and compliant code. And you have several places, several objects containing non-compliant code. For example, in this library, There's a function here. If I click on it, those are examples of SOAP connection with the SOAP protocol that I should probably evolve and replace with a more recent one. And you have other examples like that, object by object. All the time, you have this exact location of the code where you should fix the issue or rework the code in a different way. Now, let's have a look at some collaborative feature. For example, if you have to share the result of your search with other colleagues, that would change each of them their part of the code. Or if you have to generate a report, maybe to comply with some regulation where you need to check and report on the vulnerabilities in your code. So first, let's see how to share results, for example, with people from my team. You may have noticed that when I was opening a rule to identify all the functions that do not comply with this rule, there was a new tab opening here in the tree view, and I can navigate from one tab to another. But in each tab, I can analyze one by one each issue. Well, for example, I have hyperlinks telling me more about each of the items in the code. And if needed, I can also navigate in the code. Anytime I have a function, I can click to see its definition, study what's behind a function that is called, etc. Bottom line, once I check the issue one by one, I can either keep them or remove some of them if I want. And then when I get the final list, this is the result that I may want to share with my colleagues. So first of all, I can rename this view because that's something that we need to fix, blah, 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 okay? And then I can share the view, which means it will be actually uploaded in the repository, the Visual Expert repository, where we store the description of the code that is shared with all the other people using Visual Expert. So if I save this view, anyone else from my team can then come here and load a shared view from the repository. That's the one as just shared. And if I download it, then I get exactly what I had before on the other workstation where the analyst was doing his job. It means I can still navigate, use all the features, have all the information behind this view sitting in the repository that I can leverage to navigate and analyze the code or fix it if needed. Now, when I'm the developer who needs to actually change the code, once this list is properly analyzed and validated, I can take them one by one and open them directly in the PowerBuilder IDE. That will open the corresponding painter. Then I can make the change I want to make. Now, if I want to generate a report, for instance, like we said, to comply with security regulation, where from time to time I need to provide a report to the authority showing that my application is not containing any vulnerability, you can open this tab, documentation, and set the documentation that you want to generate, define a path, customize the content to include more or less details, the style as well. Once it's done, you generate the documentation and then you open it. Then you get an HTML set of pages that I can view in my browser by clicking on this button. This is the report generated. There's a number of code review sections right here. The one that is of interest for us today is this one, code inspection. And I get, again, the list of rules that my code is supposed to be compliant with. And for each vulnerability issue, I can, as we did before, click to get a description, the documentation about the rule, find the functions that are not compliant, see their code, etc. Okay, let's summarize where we are. We scanned the code, found vulnerability issues, made a list, then somebody analyzed the issue one by one to keep only those who are relevant and that should be fixed. Then we shared, if needed, this list with one or several developers that will make the change in the code. Now, I'm the one who should change the code. What I need to do now is make sure that the change I'm about to make will not break the application or have some kind of negative side effect. And for that, I need to evaluate the impact of the change. To do that, I would take a look at the code. So for example, this is the function that I need to change. If I want to know where and if this function is used anywhere in my application to evaluate the consequence of the change, I can use this feature called impact analysis. And it shows me that this function is used in this library object control and retrieve event. And if I click here, so I have a tooltip telling me more about this particular retrieve, but if I click on it, I would see the code of the event. And again, there's a red pin and a yellow highlight to show where this function get product name by ID right here is called in the code. There may be several places like that. And for example, if I'm about to change, I don't know, a prototype of a function, then I need to propagate the change of the prototype to any place where the function is referenced. And I'm mentioning this impact analysis feature because whatever the change you make in the code, it's very important. This is a key feature. You will always want to make sure that what you're about to do will not affect the application. It's not only in the code, it could be any change in the data. If you change something in the database and there's a, let's say, a column that is changed in the database, and you want to know where this column is used anywhere, you run the impact analysis and it will tell you exactly in which data window. For example, this one has a retrieve SQL where the column is used, or event in an embedded SQL reference to the column. So no matter the change you're about to make, you can always run an impact analysis on this particular item you want to change. That's how you secure the change, and that's how you avoid unexpected side effects. Now that we have seen the entire process, from analysis, detection, fixing the code, etc., let's see if and how we can automate this process in order to check regularly anytime there is a new build, for example, if there is any vulnerability in the code. So there are different ways of triggering the code inspection. You can launch it on demand by clicking on a button in the Visual Expert UI. But that's not automating. You can use a Jenkins plugins that is provided with Visual Expert to add a job to inspect the code automatically in a Jenkins pipeline in a continuous integration workflow. You can also schedule it with a built-in scheduler within Visual Expert, where you can decide that you will inspect the code every day, for example, or at night, you name it. And finally, you can also use and run Visual Expert in command line, which allows any kind of integration with another tool. Because with the command line, you can run the analysis, analyze the code, generate a report. There's a certain number of actions you can do to automate this process anytime you need. We also mentioned before when we created the project that you can fetch the code from different sources. There's even Amazon on top of the list that is mentioned here, but essentially, when it's PowerBuilder code, that would be from either directly Windows folder or from a source control. If it's database code like Oracle or SQL Server code, you can fetch it directly from the database on top of the rest. And once the code is found, the analysis will go on and the result will be saved in the repository. Then later on, people can leverage the result, browse the code, run impact analysis like we did. Now let's see how this can fit in a continuous integration workflow. You would have a classical first step of your CI workflow, whether you use Jenkins as an automation server or GitLab or any other tool for that. The usual first step would consist in getting the PowerBuilder code, compiling, generating a build, putting the build in the proper location. Then this build would be automatically tested with an automated testing tool. And in case you want to take a look at automated testing for PowerBuilder in particular, and even PowerBuilder and PowerServer, I do recommend that you take a look at the tool called Essential Test because it's specifically designed and has a tight integration with PowerBuilder to manipulate any PowerBuilder windows, data windows, and leverage all the features of a typical PowerBuilder UI. But that's for automated testing. Then on the other side, you would have a code inspection job leveraging all the features we just discussed today to check for security vulnerabilities, possibly quality issues, maintainability, bugs, etc. as well in the same process if you need. Then at the end of the process, either you pass all steps or not. If not, you come back to development. And if yes, then you can go to delivery. This is the ultimate implementation of code inspection and code vulnerability detection. And I think we may have now a few minutes left to answer any question you have about this presentation. So if that's the case, please go ahead. I'll be glad to answer them. Thank you.